Hello, I'm Sankan. Welcome to the video presentation on the angle between lines of regression. Today we will explore this fascinating concept and its various applications in computer science and engineering. The angle between lines of regression is a powerful tool used to analyze the relationship between two variables. By calculating this angle using a simple formula, we can gain valuable insights to complex data sets and make more accurate predictions. In this presentation, we will delve deeper into the formula and explore its many applications in different fields. What are lines of regression? Regression means going back or taking a step back. Regression analysis is a mathematical way of establishing an average relationship between independent and dependent variables. We can then use this relationship to predict future results or study past data. In this presentation, let us learn about lines of regression and the angle between them. If this straight curved line is a case of linear regression, then a straight line is called line of regression. Regression lines are lines of best fit, so they try to cover as many points from the scatter diagram as possible. These lines express the average relationship between variables. In linear regression, we find the lines of regression by concept curve fitting using principle of least squares. Why are there two lines of regression? The method of least square minimizes the sum of squares of the errors from specified value. Depending upon which variable we select as the dependent variable from x and y, there can be two lines of regressions. Line of regression of x on y. We use this line to find value of dependent variable x for a given value of the independent variable y. We use the least square method to minimize the squares of the errors of the available values of y from the mean value of y, which is y dash. Line of regression of y on x. We use this line to find the value of dependent variable y for a given value of the independent variable x. We use the method of least squares to minimize the squares of errors for available values of x from the mean value of x, that is x dash. The formula for lines of regression. The line of regression of x on y is given by the equation x minus x bar, which is equals to r into sigma x by sigma y into y minus y bar. The lines of regression on y on x is given by the equation y minus y bar is equals to r into sigma y by sigma x into x minus x bar. Here x bar is the mean value of x, y bar is the mean values of y. Sigma x is the standard deviation of the values of x and x bar, x from x bar. Y dash, standard deviation of values y from y bar. R is the correlation coefficient. According to these formulas, we can see that both the lines pass through the point x bar and y bar, thus the intersection of these two lines. Angle between the two lines of regression is a measure of relationship between two variables. It represents the angle between two lines that best fit the data points for each variable. The formula for calculating the angle between lines of regression involves finding the slopes for two lines and using trigonometry to determine the angle between them. We have seen that two lines of regression intersect at a point x bar and y bar. Therefore, for a correlation that is not perfect, the two lines will be at an angle theta to each other. The angle between these two lines, theta, can be found by the formula which is given below. To understand this concept better, consider an example where we are analyzing the relationship between the amount of time spent studying and the grade received on a test. By plotting the data points on a scatter plot and fitting lines of regression for each variable, we can calculate the angle between the two lines and determine the strength of direction of relationship between these variables. Applications in engineering. In engineering, the angle between lines of regressions can be used to analyze the relationship between different variables in various fields. For example, in civil engineering, it can be used to study the relationship between the strength of a material and its composition. In mechanical engineering, it can be used to analyze the relationship between the speed of a machine and the force required to operate it. In electrical engineering, it can be used to study the relationship between voltage and current. By understanding the angle of regression, engineers can make more accurate predictions and gain better insights into the behavior of complex systems. It can also help them identify areas for improvement and optimize their designs for maximum efficiency. Applications in computer science. In machine learning, the angle between lines of regression is used to measure the similarity between two data sets. By calculating the angle between the lines of regressions for each data set, we can determine how closely related they are. This can be useful in tasks such as clustering and classification. In data analysis, the angle between lines of regressions can be used to interpret relationship between two variables. If the angle is close to 0 degrees, it indicates a strong positive correlation, while an angle close to 90 degrees indicates no correlation or a weak correlation. Angle between lines of regression in machine learning. The angle between lines of regression is an important concept in machine learning, particularly in classification of regression problems. It is used to measure the relationship between two variables and can help us determine how well a model fits the data. The formula for calculating the angle between regression involves finding the slopes of two lines and using them to calculate the angle. One example of how an angle between lines of regression is used in machine learning is linear discriminant analysis. LDA is a technique used to find a linear combination of features that separates two or more or classes of objects or events. The angle between lines of regression can be used to find the direction of its linear combination. It can be used to classify new data points based on the new positive relative to it. Let us consider another example on lines of regression in machine learning. The angle between lines of regression is used to determine the similarity between two datasets. For example, let us say we have two datasets representing the heights and weights of individuals in two different populations. We can calculate the angle between the lines of regression for each dataset to determine how similar or dissimilar they are. If the angle between the lines is small, it indicates that the two datasets are similar. On the other hand, if the angle is large, it indicates the datasets are dissimilar. This information can be used to make predictions about new data based on its similarity to existing datasets. Angle between lines of regression in data analysis. The angle between lines of regression is a useful tool in data analysis as it helps us understand the relationship between two variables. By calculating the angle between two lines, we can determine whether the variables are positively or negatively correlated. If the angle is acute, the variables are positively correlated, while if the angle is obtuse, the variables are negatively correlated. A right angle indicates no correlation between the variables. For example, let us say we have a dataset that contains information about height and weight of a group of people. We can use the angle between the lines of regression to determine whether it is a correlation between these two variables. If the angle is acute, we can conclude that there is a positive correlation between height and weight, meaning that the taller people tend to weigh more. On the other hand, if the angle is obtuse, we can conclude that there is a negative correlation between height and weight, meaning tall people tend to weigh less. Advantages of using angle between lines of regression. One of the main advantages of using angle between lines of regression is that it provides a measure of strength and direction of correlationship between two variables. This allows for more accurate predictions and better insights into the data being analyzed. For example, in machine learning, the angle between lines of regression can be used to determine the similarity between two sets of data, which can be then used to classify new data points. And another advantage of using angle between lines of regression is that it is a simple and intuitive method that can be easily understood by non-experts. This makes it a valuable tool for communicating insights and findings to a wider audience. Additionally, because the angle between lines of regression is based on linear regression, it can be used with a wide range of data types and is not limited to any specific domain. Limitations of using angle between lines of regression. While angle between lines of regression can be a useful tool in many fields, it is important to note its limitations. One limitation is that assumes a linear relationship between two variables, which may not always be the case. If the relationship is non-linear, using angle between lines of regression may lead to inaccurate results. Another limitation is that it may not be appropriate to use Angle between lines of regression when dealing with small sample sizes. With small sample sizes, there may be not enough data to accurately determine the relationship between two variables, making the angle between the lines of regression less reliable. Understanding the angle between lines of regression is crucial in fields of computer science and engineering. It allows us to analyze the relationship between variables and make more accurate predictions. We have seen how it can all be used in machine learning, data analysis, civil engineering, mechanical engineering, and electrical engineering. By using this method, we can gain better insights into the behavioral systems and structures, leading to more efficient designs and processes. However, it's important to note that in mind the limitations of this method and when it may not be appropriate to use.